In this video, I'll give a basic introduction about how to instantiate different uh, transistors and different voltage sources. So firstly, we'll open the schematic editor. Then the, these three are for zooming in and zooming out. If we press F, this is known as field view. Uh, okay. So to instantiate a device, you press the word I, the letter I. So instance. Now, for example, here I'm having the 65 nanometer library. In your case, you might be using 180 nanometer library. In that case, you have to select 180. For instance, now I am selecting CMOS 065. Uh, Now let's say I want an NMOS device. So I'll press NSVTLP, uh, close. Here I can choose the dimensions. For example, and those are by default in micro. So let's say I choose one. Length, let's say I choose 0.5. Enter. Now I'll place it. Okay. Now if I press F, it will be auto zoom. F. Okay. Now let's say I want a resistor instance again. Now the resistor is not there in CMOS 65 library, so you have to go to the analog library, analog LIB RES. Now this is the resistor, P resistor. Hide, click, escape. For escape, by pressing the escape, you will move out of the. Now let's say I want to connect these two nodes. Let's say this is a common source and I want to connect these two nodes. Press W. W means the shortcut for wire. Click at this node, click at this node, and this is done. Now, I also want a VDD source and ground. So again, I click I, VDD. Again, I press F. Now, what I can do is, this is per se not a source, but uh, a better way of making the schematic. So for instance, normally what happens is we directly connect this node with a VDD voltage. But it is better to connect with a structure like this and then connect the DC voltage here. So again, I'll press I. Now for VDC voltage, the cell name is VDC. Enter, hide. Again, I place it here. Escape. Again, I press I. Now this time I want ground. So G and D. I place it here. So this is a better way of making layout. Instead of directly connecting this VDC source to here using wires, you could very well use this VDD structure and V ground structure for reference. Now I connect the ground here as well. For moving anything, just click on it and press the key M. Now this is moving. Now we can see a wire. So these two are connected. The source of M0 is connected with the ground. Now I want to connect the body to the ground. So again, I click W, click on body, and click on the ground. Yeah, so now they are connected. Let's say I want to edit the resistance value. Click on the resistance Q. It is 1K. Let's say I want 10K. Enter. Okay, it is set. So for example, you may have some doubts about like K is for kilo, but M is not for mega. It is for milli. So for mega, you have to use MEG. For example, MEG and not M. This is 10 milliohms, sorry. But if you want 10 mega, use MEG. You could look it up in Google or web. You can get good blogs and reports on it. So for instance, like let's say we are keeping it at 10K, enter. Now I have to like connect it to some DC voltage to set up the bias. Again, I need a DC voltage. Or what I can do is I could directly copy this. So I select it, press C. Now I have a copy. Again, I use the wire to connect them, W. Again, I use copy to copy the ground. And now I have to give the VDD supply. In 65 nanometer, we generally give 1.2 volt. So I'm giving 1.2 DC voltage. And here I am giving, let's say, 600 millivolt. Now I have not done any calculation. It is on rough estimates. But when you are giving any voltage, it is better to first do some hand calculations and then move on to the simulator. Okay, we have this. Now I'll save it. Now let's say I want a DC simulation. I want to check whether this M0 is in saturation region or not. And what are the voltages, node voltages, for example, if I want to know. I'll move to the launch. First, after any changes you make to the schematic, the first thing is you save it. So here we can save, check and save. And one thing the save does is if there is any error, you will not be able to save it. For example, let's say I delete this wire and these two nodes are floating and I try to save it. It will throw up an error, right? So again, I'll connect it with a wire and again I'll try to save, and this time it is saved. So it serves two purposes. First, it will save it, and second, it will also check for any floating nodes and stuff like that. So now we'll launch the ADEL. We are in. Now the first thing is go to artist kit, right click, set up corners. Now I am selecting the default values. You may want to change it. Save model file, save scenario. Then we close it. This is done. Now I want to do the DC simulation. Save DC operating point. Click enabled. Yeah. Okay. Now just run it. Now here you can check whether there is any error or not. This is the Spectre output file. There are no error. There are two warnings. You could ignore them. For instance, now the results are here in result window. Result, print. You could either print the node voltages or the operating points. So for instance, let's say I want the operating points. So I click here. Now I have to click on the device. For example, I want the operating point values of different parameters for M0. I click on it. Now this gives me the value of all the parameters that I might want. So yeah, so different capacitances. So our interest is on GM. Let's say this is GM, GMB, ID. ID is 11.72 micro. Then region. So region is 2. That means it is in saturation region. If the region were in 1, for example, if this transistor M0 was in region 1, that means it is in linear region. If it is in region 0, that means it is in cutoff region. So you can directly get the value. So region is 2. R out is 584K. So what is R out? This resistance RDS of this. That is 584K. Then you have the VDSAT voltage 158.6 milli. Then you have the early voltage. by using which you could calculate the lambda, and you also have the threshold voltage. So these are the parameters that you might want to calculate the circuit parameters and different values of current. So for example, for designing, you obviously need the threshold voltage. Then you might need the saturation voltage. Uh, you might need the lambda parameter. You might need the mu and COX parameter that you will get here. A beta factor. Where is it? Yeah. So this is that parameter, beta factor. This is equal to mu and COX into W by L effective, right? So for example, here W by L is 2, but that is not effective value of W by L. So what happens is during fabrication, there are certain mismatches, and because of which this W by L ratio might vary. So this tool accounts for that as well. So yeah, so that is something you could maybe find some more info about this from different sources on the web. So yeah, here you could get all the design parameters and as well as check the region of operation. So it is 2. Okay, let me cut it. Now R0. I want the parameters across this. I click it. So the current is 11.72. The power is 1.374 micro, and the resistance value and the voltage. Get it. So yeah, this is the DC simulation. Now let's say I want to vary this DC value. That is the VGS value, and I want to note the current, let's say. So how do I do it? So firstly, I have to cancel the simulation. I have to come out of the simulation. So no, yeah. So after coming out of the simulation window, you have to click on the VDC. So I've clicked on it, then Q. Now this is a constant value. What I'll do is I want to vary this value, right? So what I'll do is I'll use a variable. Let's say VGS is a variable, enter, and I'll measure this current, this ID current. So first of all, I'll save this. Again, I'll launch it. Again, the first thing is go here and set up the corners or save model, save scenario, close. Again, I'll do DC sweep. Oh, okay. Before even setting up the simulation, you have to go to the variables. Since we have taken one variable, so we have to first give a default value to it. So variables, copy from the cell view. So you'll directly have the variable that you have declared there. So let's say, for instance, let's say we take it at 600 milli. Okay, let's take it at 600 milli. Uh, Simulation. I want DC operating point. I want to sweep the component parameter. Click here, select the component, this component. I want to sweep the VDC voltage. Okay. Okay, here I am. Now I want to sweep it from 0 volt to the maximum voltage, that is 1.2 in our case. Okay. So I have set it up. Now by doing this, part, what I have done is I have created this x-axis. But what about this y-axis? So for that, what I have to do is I have to select this node in the design so that this ID is selected. So for that purposes, uh, so for that purpose, what we have to do is we have to again move here. We have to click on this, set up outputs, click from design. Click. Now I want this node this node or this node, any node, double click. So again, two currents are selected. This circle means current, right? Two currents are selected again. Okay, I don't know which is from which point, so I'll not select both. And again, from design, it's better to select this. Okay, not selected. I'll select this. I'll delete this M3 net again. So I want this M0 backslash D, which means the drain current of M naught. Circle means current. Okay, so I have the setup. Now, basically, what has happened is that I have both. I have both the x-axis, which is given by this part. The sweep is giving me the x-axis, which is a voltage, and this current is in the y-axis, right? So I have a graph based on that. So again, I'll clear everything. Now, okay. Now I have to just simulate it. Yeah. So basically, this is the graph: current versus DC, VGS, ID versus VGS. Yeah. So this is the graph.